Hi, in today's lesson, we discuss question 36 of HSC Physics 2019. A radon 198 atom, initially at rest, undergoes alpha decay. The mass of the atoms involved are shown in atomic mass units U. So here we have radon 198, which undergoes alpha decay and splits into helium, atom of helium, or more accurately, nucleus of a helium, which is alpha particle, and polonium 194. And these are the masses of each particle. So for radon, we have a mass of 197.999 in atomic mass unit, and for polonium is 193.988, and helium is 4.00260. The kinetic energy of the polonium atom produced is 2.55 times 10 to the minus 14 joules. By considering mass defect, calculate the kinetic energy of the alpha particle and explain why it is significantly greater than that of the polonium atom. Okay, the first thing we do is we find the mass defect. Mass defect is the difference between the total mass of the products and the total mass of reactants. So here we have only radon with that much of mass, which produces these two particles. So we add these two masses and take it away from the initial mass. And this way we see how much mass defect exists, how much of the initial mass we have lost. So if you do that, 197.999 minus the sum of these two, you end up with 0.0084 atomic mass unit. Now for energy, this based on the equation E is equal to mc squared, E equal to mc squared, that will turn into energy. How much energy we have is this mass defect times by initially what we're doing, we are changing this into kilogram because in the formula E is equal to mc squared, you need to have your mass in kilogram. So that is the mass defect, how much mass we've lost. We change it into kilogram by timesing by this factor. So 0.0084 times that factor, which is the conversion from atomic mass unit to kilogram, gives us that much kilogram. And then using E is equal to mc squared, we have that much mass times by c, the velocity of light, which is 3 times 10 to the 8 squared, and we get this value, 1.256 times 10 to the minus 12 joules. That is the total energy produced due to mass defect. Now, where does that energy go? It appears in the form of the kinetic energy of the two particles, radon and alpha. So radon has been given to us, which is that much, So, and that's the total. So we subtract that from the total and we get that much joules. So that is the energy of kinetic energy of the alpha particle. I use the kinetic energy and A for alpha. All right, so this is all based on the conservation of energy. So mass change into energy. Now, where does that energy go? It goes into the kinetic energy of the particles, and they share. In the next part, they are saying by considering, so we've done this bit, explain why it is significantly greater than that of the polonium atom. Why alpha particle, which has much less mass than polonium, still has a higher kinetic energy. To answer this question, we use the conservation of momentum. Conservation of momentum states that initial momentum is always equal to final momentum. So the total momentum of the system before and after collision is the same. So because they told us that radon 198 is initially at rest, means our initial momentum is 0. So then the final momentum will be also 0. On the other hand, we know that the two particles which we have, alpha particle and polonium, both have kinetic energy, so they have a velocity. But to have a total 0 momentum, we need to have the velocity in different directions, and also the absolute value of the momentums must be equal. So momentum is velocity times mass. So for particle alpha, if we show velocity with VA and its mass with MA, then we have VA times MA equal to the momentum of polonium, which is VP times MP. VP means velocity of polonium, and MP means mass of polonium. Now that we have that, we can rearrange it in this form. But we know that mass of polonium to mass of alpha is 48.465. So polonium has a mass which is about 48 times larger than mass of alpha. On the other hand, we know that kinetic energy is proportional to mass times v squared. Or if you want to write it as equality, it is just E is equal to half mv squared. Half mv squared. So now why alpha has a higher kinetic energy? The reason is, well, it has lower mass, which is about 48 times smaller, but its velocity, as we can see from here, is roughly 48 times larger. But velocity, if that was just velocity, then the total kinetic energy of both particles would have been the same. One has higher mass, one has higher velocity. However, because velocity is squared, that means your alpha particle will have a total of 48.465 times more kinetic energy. As we said, mass is lower, but velocity is squared. Mass is lower by 50 times, by 48 times to be more accurate. But velocity squared is over by, if we consider as 50 squared is 2,500. I've got here the exact value. So this is squared is 2,348.9. So that is the reason alpha particle has a higher energy. So it all comes from the fact that we have a conservation of momentum. Thank you for your attention.